Kia koto, ahia himari, ko nishato ko ingoa. Good afternoon and welcome everyone to session 2 of NZRSE 2023. I'm Nisha, I'm the training lead at NZRSE, and I'll be chairing this session that predominantly focuses on skill development and training approaches. We have four very interesting talks, three, lined up this hour, starting with a full-length presentation by Matt Plummer from Victoria University of Wellington. But before I hand over to Matt, if you want to chat with someone specific, perhaps a presenter after their talk or a delegate after your networking session, for example, that you just had, do make use of the Meeting Hub option, which is located on the right-hand panel of your screen. And do keep an eye out on notifications in case someone's trying to reach out to you. Finally, if you're having any technical difficulties, please click on the red live support button, which is located at the top right corner of your screen. Please feel free to pop in any questions or comments through the course of the session into the live Q&A chat box, which you can access by clicking on the box at the bottom of the screen. You'd see a panel. There's a box there that says live Q&A. So feel free to make use of that. So let's begin this session by handing over to Matt, who's going to talk to us about What's Up Talks, documentation, collaboration, and community building. Over to you, Matt.
Koutou katoa, ko Matt Plummer tōku ingoa no te kōhuri o te Herenga Waka Aho. Hi everyone and good afternoon. I'm Matt Plummer from the research office here at the Victoria University of Wellington, and I'm co-presenting today, although I'm taking the reins on that, with my former colleague, Angelin-Bonnet, who is a key participant in this process, as I'm sure will become clear as this presentation goes on. And it's my pleasure today to talk to you a little bit about the role of documentation and documenting key aspects of our performance computing cluster, Rapoi, over the last few years, and how that's helped to transfer knowledge, create a collaborative space for capturing that knowledge, and also developing over time an ecosystem where our users can also directly contribute to that. Because I think it's often an overlooked component, documentation. It's often seen as a background task, something that people kind of get to, and when you're in the middle of doing something new, you don't always necessarily want to spend time documenting the steps that have been taken. But we're at a point in the service here at Victoria University where there's quite a changing of the guard, and I think it's becoming increasingly relevant, the importance of that knowledge being captured, but also how we continue to improve on it. And that's what I'm going to be talking with you about today. So just a little bit of background context for this project. Up till 2018, there was no central research computing resource at Te Herenga Waka. There were different clusters and different sort of pieces of resource for different research projects. And there was, however, a science faculty or SciFac computing cluster that was homed in the Faculty of Engineering. There was a dedicated support role, any research consultant who looked after the cluster, and there were about 40 user accounts when we inherited this cluster in 2018, and it made use of the SunGrid scheduler. And when I say we in that last statement, we were a small research support team that had recently been repositioned in the university from our central IT department to a Centre for Academic Development, and we just happened to have some of the skills that were useful in administering an HPC environment, which was very convenient because the Faculty of Engineering didn't replace the e-research consultant support role that had previously held the reins. So we inherited this cluster, and we were lucky to have Angelin as my good colleague, who just happened to have the skills to be able to sort of, from the ground up, re-envisage and re-engineer our HPC. And we're also incredibly lucky to have Wes Harrell, recently arrived from Boston, looking to sort of get his his sort of hands into the e-research system here in New Zealand, and we were incredibly lucky to have his expertise and support working with Andre to take advantage of this opportunity. And what Andre and Wes did was decide to do a little bit of a shift of course in terms of how that HPC was configured, most notably looking to align as much as possible with our colleagues in NZRSE in terms of how the hardware and software was configured. So they changed from SunGrid to the Slurm scheduler and looked as much as possible to align the operating system, CentOS. The reason being that we realized that a number of our researchers either were already or would benefit from using NZRSE, and so creating an environment which was as familiar and similar as possible would have benefits to our researchers, and that's what they did. So there was quite a lot of work that was done, as I'm sure many of you could imagine. And then the next step was, how do we document this? How do we sort of create a new set of information to our users, noting that the sort of the configuration and also the focus of the service had changed, because now it had moved to a central part of the university. We were quite keen to sort of extend the reach of it to disciplines beyond the science faculty, and to get new users from different parts of the university involved, and realize that a bit of an onboarding, induction and documentation about how you might do that would be helpful. We also created a Slack workspace as a kind of social space where our users could gather. And long story short, sort of 6 years or so later, or 5 years later, we've now got roughly 80 active weekly users who see this as a really essential resource for their research. And there've been nearly 400 accounts created over that time. Obviously, there's a bit of attrition and some people leave, but it's been a service which has become increasingly important. And I want to talk a little bit about how the documentation has supported that today. So kicking off this process was Wes, who I mentioned briefly earlier, and a sort of integral part of this whole process. Couldn't have been done without him, I think Andre would agree. And being the sort of very pragmatic person he was, he had some key information he wanted to convey. He created a Jekyll theme and quickly documented some of the original points at a very high level about the cluster. He used a theme which I notice is a favorite of another colleague and a member of today's session as well, Murray Cadzow, down in Otago. But as you can see, the colours were quite Otago themed, and it was a really useful starting point. But I sort of took on the reins of seeing if we could customize it and make it feel a little bit more specific to our institution. So what I did was I had a bit of a hunt around. At the same time, also thinking about, was there a different deployment option or different sort of templating option that might fit the purpose? I noticed that something called MKDocs is very popular for documenting technical projects. And what I did was I took on a Read the Docs theme from MKDocs and put in a bit of CSS and web design, sort of mocked up a logo, and then created which is more or less the sort of the design aesthetics of the documentation, which persists to this day. And being someone that was quite aware of the need to remind myself what to do in this process, I quite painstakingly documented in a README file in our GitHub repository, step by step, the process it would take to update this process. I should just pause here to mention that invaluable in all of this was using GitHub, both as a way of using GitHub pages to deploy and publish the documentation, but also as a kind of collaborative backbone which has version control and the tools and the infrastructure set up to do exactly what we've done. And so quite a arduous but fun process. I think there are about 12 steps in this updating to reconfigure the docs at that point in time, and it was really myself, Wes and Andre that were sort of working on it at that point. And then over time, Andre became more or less the sole key support for the cluster, and did a huge amount of work documenting technical aspects of the cluster so that our users could understand it better, but also thinking about these kind of step-by-step exercises for different cohorts, different groups within our community, our broad community, which, as I mentioned earlier, now spanned a range of different disciplines. so that they could get started. So these step-by-step examples, everything from MATLAB to R to a bash script, and using the docs as a way of providing that sort of onboarding. He also used it to sort of help show the interrelationship and components of the cluster and how that might affect different job submission types, using the functionality of things such as Mermaid.js, which you can see in the two diagrams on the right there, that could just be automatically rendered within the docs ecosystem. And I think some people find this, I know I do, really useful to get a sense of what is happening here. It's one thing to see a rack with a whole lot of servers on it. It's another thing to link that to a sort of interlocking component of a cluster and then apply that to how a job might be submitted when you're submitting the job to the cluster. But Andre also, in the spirit of continuous improvement, took something a step further in terms of optimizing it. Those kind of painstaking step-by-step MK docs processes that I had gone to the trouble of documenting earlier, he made that totally irrelevant by sort of using GitHub Actions and workflows and continuous integration to basically automatically deploy once a commit has been added to the docs. So that was a really nice improvement. A bit of work up front on Andre's part, but made the whole deployment process easier. And one of the affordances of that is then it also became much more easier for people wanting to contribute to the docs or new people supporting the cluster to sort of add information to them. And what we saw from that was some really cool case studies where some of our users saw an opportunity or saw a missing space in our documentation and added that to them. So I've got an example here from Jeffrey Wheel, one of our postdoctoral fellows, a key user of Rapoi, who saw an opportunity to add some more information on VPN and access. The other thing that kind of motivated Andre, I think, to add that was we were realizing that we use Slack extensively, but only on the free tier. So at a certain point, information in that workspace starts to drop off, and we sort of intuited that certain groups within in Slack, different disciplinary areas, had sort of had information relevant to them about how they were using it. So we thought we really want to capture that, if possible, in the central docs where appropriate. And so providing an opportunity and a platform where some of that knowledge that had been developed within our user community at least had the potential to be added to the central docs was created. When we surveyed our users, this is some survey data from a few years ago, I think 2020 from memory, what sort of help and support that was received. Reading through the documentation was the most common support that was common to everyone, which is kind of what you hoped. And when we onboarded new users, this was certainly something we always pointed to in the welcoming email, is that there's a Slack space for lots of community building and where you can ask questions and get help, but also please read through these docs because they have been developed with you in mind. And it was really, I think, a cool measure when we could start, if you wanted to trying to figure out what the URL was or remember going back to it, you could just start typing Rapoi into Google, and it was at least with a little bit of indexing, the first thing that comes up. So that was a nice sort of sign that the docs were doing their bit and they were being used. More recently, the university's been unfortunately in a state of financial challenge, and so a number of services in this space, including Rapoi, have become sort of questioned as to the value that they have. So the first thing when I realized that Rapoi and the value research community was sort of needing to be demonstrated was I went to the docs. I went to our docs. I created a step-by-step guide because I realized that with our new elements, our research management system, we could actually link that resource, that Rapoi resource, to publications and outputs, research grants, and so on. And so that seemed to be one of the most useful, pragmatic things I could do in the state of uncertainty, was like make sure that our community knew how they could link their research and demonstrate the value of this cluster to sort of the outputs that they have. And so that's what I did. And when I did this, I used the demonstration sort of snapshot, and you could see it's a little bit small, but on the right there, one out of one of 7. So at this point in time, a couple of months ago, there were 7 publications that one of our postdocs had proactively figured out how to do this linking process. It's not arduous, but you kind of need to know that it's there. There were 7 publications. Within a couple of months, there were over 180 publications and I think 23 grants associated with the service. So it was an example of how we could use the documentation to help people in our community show the value of the cluster to their own research. And it was really great to see the community response. So here we have a combination of Slack and emails and our research information system elements and the Rapoi docs helping to create this sort of very clear, not exhaustive, but really good start to showing sort of how often the service is used in our research. Over those people that have contributed to the docs have also grown, and so we've got over 11. We've got 11 contributors over the years now. Some in the top left of that image, no longer necessarily actively involved, but it's also been a really great way of passing on knowledge to new administrators and new people supporting the service. And the best way, I think, to sort of demonstrate that activity is to use a visualization of our Git docs GitHub repo. So this is going way back in time. Wes kicked it off. Then I started to do some work on the development of the MK docs. And then in the sort of intermediary time, we see a whole lot of work being done by Wes and Andre, finessing, refining, customizing, adding more information, fixing typos, responding to requests. And then just towards the end of this video, you'll start to see, and it's coming up right now, all of a sudden, the last couple of months, a real burst of activity when there's this sort of handover, when we realize that that on to a new opportunity, and we needed to find some ways to sort of pass on that knowledge. So we created a way where there'd be a new role of a moderator, that some of the administrative work that Andre had done would be taken over by a digital solutions team. And then all of a sudden, there's a whole lot more people. This is just the docs, just acting in that space. So quite a nice way to visualize that community. And just as a final thought from me, and this is sort of, I guess, my own personal interaction, but it's been a really great thing to see this sort of local cluster gather momentum, gather users over the years, and sort of become a really invaluable resource. And one of the things that's left from that initial effort, now that Wes, Andre, and myself are no longer directly involved in supporting the cluster, is this sort of collaborative knowledge system that will continue to be improved upon, but there's a basis to work from. And so I kind of like that idea of finishing with this concept of documentation as a living legacy of obviously the change over time, the components will get outdated, the docs will become old too, but there's a sort of a backbone and a sort of a basket of knowledge that has been contributed to that enables this new community of admins and moderators to help continue to support our researchers. And I think with that, that is me.
Thank you for that brilliant presentation, Matt. It's incredibly useful for some of us to understand the kind of resources we need to get the documentations in order and the kind of collaborative approaches we could possibly take, because not a lot of us know how to go about it and get started on that. Thank you. So just pausing for a minute. I know we are just being wary of time. Please use the live Q&A box to type in any questions you might have. And I can see one from Wolfgang. Would you expect LLMs like ChatGPT to be useful for generating such documentation? It seems good, for example, documenting code, but I'm wondering if it is similarly useful for cases that require a lot of specific external knowledge, that is, such as system setup. Maybe if that setup is defined through infrastructure as code.
Yeah, kia ora, Wolfgang. Yes, I think that artificial intelligence and those large language models can have a lot of sort of shortcut saving, particularly when you've got a concept and you want to help phrase that idea, and also, as you say, on the technical aspects of code. I don't think there's any substitute for that human-centered knowledge that those kind of AI tools can help maybe express and sort of articulate efficiently and effectively some of those concepts. And it may be that in the future, performance computing clusters are run by AI bots. I don't know. Might be putting a few people out of jobs, but it is an interesting question. Thank you for that.
Yeah. One more from Maxime. Did you get any feedback from non-Git, non-Markdown users that found it hard to contribute to the docs?
I think that I haven't had that feedback, and I think that's one of the things that we really really focused on, was trying to either document really clear step by step the process, or make the technology involved as simple as possible. And Markdown with tools like HackMD has been, I think, a relatively quick sort of concept for people to grasp. I certainly know, grappling with HTML back in the day, not so much how hard it was, but how time consuming it could be, that some of those tools are good. And that's another area where ChatGPT is incredibly helpful. You can get a markdown table in a second if you know what you want. So thank you for that.
Yeah, thank you. Kira, Matt, seems like that's it for questions.
Thanks, Nisha.
Thank you so much. Yeah. Next, we have Murray Cadzow from the University of Otago, who will be talking to us about a nationally collaborative approach to carpentries training in New Zealand. And this is a lightning talk. Welcome, Murray.
Cool. Kia ora koutou, everyone. Ko Murray Cadzow toko ingoa. And today I want to talk to you about a collaboration that sort of spawned out of some chats that we had during the Carpentry Connect earlier in the year. So, where's my thing there? Brief overview of what is the Carpentries. So the Carpentries is an international project that's made up of software carpentry, data carpentry, and library carpentry. There's lots of trainers, there's lots of instructors, there's lots of people all around the world developing these digital literacy curriculum. And here in New Zealand, we have quite a few instructors and people that are involved in the workshops. And we sort of have been traditionally headed up by NZRSE. So NZRSE sort of spearheaded the effort in about 2015, 2016. And since then, different organizations around the country have had different levels of engagement and delivery of the Carpentries content. Traditionally, these workshops have been 2-day in-person workshops, have some instructors, have some helpers, and somewhere between 15 and 30 attendees. One of the big things about these workshops is that the access has been fairly dependent upon which organization you happen to be in. Different organizations have different pools of instructors, and some organizations don't have instructors available to pull upon at all. And generally as a whole, there's been fairly low awareness about what each institution or organization has been doing in the way of these workshops. And so as part of the conversation earlier this year, we sort of wondered, can we sort of work together, spread some of the load across the country and reduce some of that admin taskings and things that go on behind the scenes. So thinking about going nationally, what did we want to sort of achieve here? One of the key things here was we wanted to spread the load across the institutions. So for institutions that had a few people, they could make use of other institutions that had more resources and vice versa. We wanted to reduce the barriers of engagement, so make things easier for people, try and take away those factors that were stopping people running workshops. At a national level as well, there's been lots of talk around starting a national calendar of workshops and things like that. The idea here is that we wanted to start with something, make it regular, and then we can improve it as time goes on. And secondary to what we could offer for attendees, putting my instructor training hat on, I wanted to improve the instructors and give them an opportunity to develop, give an onboarding opportunity for new instructors, and also have a role of expanding the community across New Zealand. So we've had some pilot rounds. The lesson that we chose to deliver was the introduction to Unix, largely because it's about a 4-hour workshop, so you don't end up having too much time on Zoom. It's got low installation requirements, and it's quite a good lesson to bring in new instructors. So we've had 2 rounds of this lesson so far. The first one we had was coordinated between Auckland, Canterbury, and Otago. And then the second round, we have had NZRSE sort of coordinating the efforts, and we've got Victoria University of Wellington involved as well on that end. We've had some successes, we've had some challenges. We've only had 2 workshops so far, but we've managed to get several different instructors, 2 of which it was their first time teaching that particular lesson. We've got some processes put in place about how we can crank these out over and again. It's been great to see the enthusiasm of everybody that's been involved. Some things that we're still battling with is that we have fairly high drop-off rates both at sign up and during the event. So people post lunch won't necessarily turn back up. So we're working out how to deal with that. On the instructor front, there's a lot of black boxes on Zoom. So we've been doing this online, and it can be demotivating to not see people's lovely faces, but we need to work out how to do that. And at the moment, it's been very university centric, and we'd love to incorporate more, especially of the CRIs and a wider breadth of people. So what next? We're hoping for round 3 in the middle of November. There is going to be a link put into the chat. And next year, we're hoping to increase our offerings beyond just the introduction to Unix, maybe some OpenRefine, some R and Python. And with that, I'll give thanks to Nisha, Tom, Anton, and Hayden, who were all instrumental in helping me pull this off. Cool. Thank you.
Thank you so much, Murray, for that very insightful lightning talk. And do we have any questions? I know that we're rushing at the moment, but any questions for Murray? Please use the live Q&A box. Going once, going twice. Okay, we'll let you all mull over that lightning talk, and maybe we can come back to this at the end, and we can move on to Olivia's presentation now. Thank you, Murray. Next, we have Dr. Olivia Angelin-Bonnet from the New Zealand Institute for Plant and Food Research Limited, or PFR. Olivia will be presenting on mastering essential skills, incorporating software development principles in statistical practice. Over to you, Olivia.
Thank you very much, Nisha. Hi, everyone. Thank you very much for joining me. So as Nisha said, I'm a statistician at PFR, and I want to talk about how I came to understand how to incorporate software development principles in my statistical practice. So I'm a statistician. What does it mean? Well, typically my job starts with data, and often the data that I receive is big and it's messy. I spend quite a lot of my work on data wrangling, taking the data and putting it into shape so that it's usable for analysis. I do then data analysis, exploratory data analysis, modeling, all of that. That's a big part of my work. And then from the results that I get, I have to report. That means creating presentations, slides, or writing documents on the results that I got. And sometimes I also get the chance to develop some tools that could be R packages to create specific visualizations, interactive dashboards for people to look at the results of the analysis, etc. And all of the work that I do it in R. So actually, most of the work that I do is not really statistics as much as it is coding. Now, when I was at uni learning my statistical degree, I learned how to do statistics, how to perform hypothesis testing, what a normal distribution is. I learned how to do data analysis, and I learned how to program in R and Python to perform these statistical tests, etc. However, then I joined the workforce, and I realized that actually all these things that I learned were not actually enough to help me do my job at a level that I was comfortable with. And so there are a number of things that I learned kind of on the fly that I wish I had learned when I was learning statistics. And these are things like version control, how to manage my computational environment, how to document properly, which is what we just heard about, unit testing, workflow management, all of these kind of things. So in this talk today, I would like to talk about these software engineering skills and how I think they are extremely important for the work that statisticians do. Not talking about developing proper software, but just writing code. And one of the things that we are often asked is, but why should I make time for all of this? And that's actually quite hard to justify. Why should I spend time learning how to use GitHub when my job is statistics? And one of the things that I think is a good answer is that actually all of these tools, if nothing else, they make our work sustainable. And by sustainable, I mean that it's not a headache. These tools and these principles help us to save time, make sure that the work that we do is correct, robust, reproducible, and that we are not going to waste 6 months or just a couple of hours, more realistically, trying to find back projects that we worked on a couple of months ago. However, there is a stronger justification, I think, is that in recent years, we've been hearing a lot more about the concept of open science. So in research, whenever we're publishing a paper and people can read the results of our research, they don't want to just know what we found, but they really want to understand how we got there. So what data did we use? What are the methods that we use? They want to be able to reproduce our code, our analysis, etc., and they want to see all of the steps that we took to get to our results. And whether we agree or not is a completely different topic, but the fact is that that's something that we need to strive towards. And all of these software engineering skills that I'm going to talk about are something that we need to learn in order to meet these criteria. So I just want to go through each of them, starting with the very obvious one, the concept of version control. And one of the first things that I said is I work a lot, what I do mainly in my job is writing code. So of course it seems to probably a lot of people in the audience like a no-brainer to use code versioning with tools like Git, GitLab, GitHub, etc. It offers you an access to the history of the project, so you're not looking for your scripts version 1, version 2, etc. And I don't want to talk about that too much because it's a topic that is quite well known, I think. But one of the things that I would say is that it's not often used in statistics, actually. And I found that in addition to the idea of having access to the history of the project, the other thing that it helps with is really collaborating on code. And that's something that I discovered when I joined the workforce, when I started working as PFR as part of the team, that suddenly I'm not working by myself, but I have to collaborate on code. And that's where tools like GitHub make it so much easier. It's also becoming a standardized way of sharing and publishing code. And so that's something that we'll need to learn about because that's how you share your code with your audience. However, in the concept of version control, we talk a lot about code, but something else that for statisticians is actually quite important is the idea of versioning data. And when you're learning statistics at uni and you're given an example data set, it's the same example data set that has been used for the past 10 years. You can just Google it and you can find the CSV file. It's never going to change. When you enter the workforce and you start working as a statistician, you quickly realize that actually the data that we're working with it's not static. People will realize that they made a mistake when they enter the data, and so it needs to be corrected. You're working on several multi-year project, and so more observations are added. And so it becomes really important to be able to link the results that we get from our statistical analysis to the version of the data that we used. And of course, it's important to version the raw data, but it's also important to version the process data. So what is the version of the clean data that I generated? And other process data or results that I get, like figures or tables, should be considered for versioning. Related to the idea of keeping track of things, managing computational environment is a very sweet problem to have when you enter the workforce and suddenly you're not working on your own laptop, but you have actually a shared environment and you can't install all the packages that you want. So if I had more time, I could tell you so many stories where this backfired because I had never learned how to properly manage my computational environment. But I think that very briefly, it matters because statisticians always depend on software. And these softwares get updated more or less often. And these changes have the potential to impact the results that we get because of a change in the code that is underlying the packages, etc. So that's important not only when you're working by yourself, but actually, again, as I started working as part of a team, I realized that I was working with other people and I needed to be able to make their code work on my machine, and I needed them to be able to use my code and reproduce my results. And that's where managing my computational environment became very important. On top of that, I found that now that we get bigger and bigger data sets and more complex analysis, we're relying less and less on using our own machines, personal laptops, etc., to run analysis. And instead, we are given the opportunity to use cloud platforms or HPCs. And then it becomes something completely different to what we are used to when we are learning statistics, because suddenly we can't just install the packages that we want. For example, we need to be able to test our code on our local machine safely, and then be able to replicate the computational environment on, let's say, an HPC to be able to run the same analysis on bigger data. So one of the things that I learned to use is, or learned that was very useful, is dependency management tools, things like rm in R or conda in Python. Basically, any tool that can do two things. First, record the dependencies. So for a given project, you need to be able to list all of the packages that you need to run a certain piece of code, a certain analysis, not only which packages, but also which versions did you use. And these tools also have the very nice effect of isolating project library, which again is something that you realize after mistakes happen, where working on a project and changing the packages won't impact another project that you're working on. And that is very useful and saves a lot of time. Now, on a topic that we've heard before, documentation. And in the statistical domain, I'm sure that a lot of people could relate to this idea of being brought onto a new project and being given a data set with very little context, and then asking, well, where is the documentation? Where can I find information? And the answer is, oh, try to ask this person when they get back from holiday in 2 months. Not the kind of things that you want to hear. And one of the reasons for that is, I think, in statistical degrees or in science degrees in general, what we are taught to do is to write reports, write assignments, but we're not really taught how to write documentation that allow collaboration, or even if the collaboration is with your future self. And so one of the first things that I found was extremely useful is to learn how to write proper READMEs. And maybe for software engineers, it will sound like something ridiculous, but actually it's not so obvious to people who have never done that. And not only writing READMEs, but also maintaining them and making sure that as the project progresses, you keep them up to date. Something else that is similar to the concept of, falls into the concept of documentation, but that is maybe more specific to statistician, is the idea of writing codebooks that are often also called data dictionaries. So we're working with data sets. It's really easy to be given a data set where you actually have no clue what's happening. The variable names are called variable 1, variable 2, it was raining on this day. I don't know, these weird things. And sadly, that happens a lot. And so I think learning how to properly write descriptions, not only about your project, but also your the specific data set that you're working on, is something that is very valuable to our work. For writing documentation, I found that literate programming is actually extremely useful. And by literate programming, I mean any tool or software that allow you to mix code and plain text. And that would be things like Jupyter Notebooks, R Markdown, the more recently Quarto. The idea behind it is that it's a place where you can record your reasoning, take notes, alongside your code. So you can use code to produce a figure, and then alongside this code, you can write your interpretation. I found that this was very useful to write documentation, because then we don't separate the production of the results from the actual interpretation, and you can version control the two together. But also it's very useful for reducing copy pasting. As I was saying, a lot of the work that I do, I have to report on it. And if I have to copy all of my figures or my table or my p-values, it can be very error prone, whereas literary programming can help me generate the reports directly by when I create the results. Unit testing. Now, unit testing is something, if you write any bit of software, of course, you're going to want to make sure that the software performs the task that you want it to. And that can seem a bit trivial and a bit weird when talking about statistics. But actually, I found that testing is something, again, that we are not taught as statisticians. And however, it is so helpful. And we should really learn how to write formal tests. Maybe not for software so much as writing tests, for example, for data. When I get a data set, you could be surprised by the number of things that can go wrong. Oh, there was a random comment written on the side. Oh, suddenly I wrote NA with NA and then I said missing for NA instead, these kind of things. But also we're writing, as statistician, we're writing a lot of code, but we kind of trust it too much. We think that, oh, if someone wrote a package, then of course it's going to work. And actually I learned, again, same thing as always, through mistakes, that it's always a very good practice to check your code, to check that the correct output type will be returned, that if there is an error in your data, the code will generate an error, right, rather than just returning you something that might be completely wrong. And more generally, writing formal tests to test complete analysis steps. So making sure that whenever you run a certain model, it gives you sensible results, that if you were expecting an answer, it will give you the proper answer. And on this topic, one way that we can do that is to use simulation to test statistical methods. So that's, again, something that we're not really taught in a statistical degree, but it's the idea that if you are using a model to estimate a certain parameter, you want to make sure, using simulated data, that the model you're using is actually correct. And so if you're creating a model, you want to make sure that it's appropriate to answer your research question by generating some data that will look like the data that you actually have to analyze later. Sorry. So that's a whole topic. I could talk about it for much longer, but I think using simulation studies is something that is very important for testing. Lastly, and that's the last point I want to make, is the idea of workflow management. And I'm going to go very quickly on that. But when I was writing my PhD, when I was studying for my PhD, that's something I wished I had known, because this is a little diagram of what the analysis for one of my chapters for my thesis look like. And it's very complicated. It's a lot of different analysis of different data sets. There are multiple scripts, there are multiple folders. All of the analysis depend on one another. And what do you do when something changes in the middle of one analysis, when you realize there was an error in the data set and suddenly you have to rerun everything? And after my PhD, I discovered the joy of workflow management tools. So because I work in R, I learned about the R package targets, but there are many others for other languages or languages agnostic tools like SnakeMake, Whittle, etc. But basically, it's the idea of turning your analysis into a pipeline where each of these steps are linked through their input-output. So the output of one step is the input of another step. And these workflow management tools will ensure that the steps are executed in the correct order. And if something changes, all of the steps that depend on the thing that changed will have to be re-executed. Again, just personally, it saves so much time, but it also ensures that your analysis is correct and you haven't introduced errors by changing things and not updating them. Okay, in conclusion, I think that all of these software engineering practices that I've talked about are very useful, not only for software engineers, but also for statisticians and data scientists. And that's not something at the moment that is taught in statistical degrees, but I think that it should be. However, if you think that it's something that could help you, but you haven't learned that in class, there are so many resources out there, and I will just put in the slide a couple of them that I think are extremely useful, and that's how I got started into using GitHub and using targets and all of that. So thank you very much for your attention, and I would be happy to answer any questions.
Thank you so much, Olivia. And that was the last presentation for this session. And now we can move over to the audience to check if there are any questions or comments. from anyone? Just looking at the live Q&A box, please feel free to type in any questions. So the first one's from Maxine. Amazing talk. Do you have recommendations about data versioning tools? Example, that is, have you tried Git Annex, Data Lad, GitFS, DVC, or anything else?
Yeah, thank you, Maxime. That's a great question. So I know very little in that domain. So all that I know, I owe it to some of my colleagues, in particular Blake List, who has taught me a lot. And the tool that we're using is Minayo. So it's a S3 data storage, which please don't ask me what that means. But it's something that is very easy to link with R. And basically, I can just send it my data, and it will save the data in a place where it's version. I can add metadata. If I update it, I can go back to the previous version. And something else that I've used is Pins, which is a R tool that is, I think, is starting to be used in Python as well, but same idea, the idea of sending your dataset somewhere with associated metadata, etc.
Thanks, Olivia. Some more questions coming in. So Mark Neal says, all the stuff we should do, how do we encourage others and ourselves to do it consistently?
Yeah, great question. I think it doesn't come until you've made a big mistake and you've wasted so much time that you realize, I really should learn a better way to do that. But jokes aside, I think we can lead by example. I know that since I started at PFR, I've been talking a lot about that because I think it is, if people don't see you do it, then why should we do it? But as soon as we are a small community starting to do that all together, we get excited about it. We can talk about the problems we have, and it becomes much easier to continue. But yeah, I think also insisting on what are the benefits for the user first? What are the quick things that can help you get back your time if you want? Can be a way to incite people to use it.
Great, thanks. And the last one, Wolfgang says, great talk. How did you become aware of all the different techniques and methods? It would be very useful to share these insights widely. Many users face very similar issues and challenges.
Yeah, that's a good point. So I think I started learning about maybe one or two concepts. So I started using GitHub because I was doing an internship at a place that used GitHub, etc. But I really fell into it when I started using Twitter and I started following people from the R community that were talking about best practices. And it's really a rabbit hole that you fall into. So you start following someone and then they mention a tool and then you keep following people and suddenly you learn about all of this. So one thing that I've been trying to do, as I was saying, is really try to communicate to my team the tools that I discover and the tools I tried. And I think if everyone can share the tools that they've been using, then maybe it can help make people aware of them. But it's really following the people that know and trying to grab any insights that I can get.
Great. Thank you so much, Olivia, for taking all the questions and for that wonderful presentation. If you have any additional questions pertaining to any of the other presentations as well, please feel free to message the speakers directly and they'd be happy to respond to you. You can also find them at the Meeting Hub. Now we have a short break until 3 p.m. when the next session is going to be a Birds of a Feather session starting at 3. So stay tuned. And thank you so much for your time and see you all in 12 minutes. Yeah. See you. Thank you.